As we look back in history, we discover many of the factors that make the area we live in, what it is and what it looks like. And you have to go a long ways back to find out what created the geography of this area that we have in this area. It's been a driving and creative force throughout local history. And so we're going to look back today a little bit further. I don't think there's anyone in this room that dates back this far. We're going to go back to the glaciers and we're going to take a look at what actually created the geography that we have. Tonight, kicking off this series, we have Bryan Hargrave. Bryan's got a historical connection here to the Pillager area. I know the Rolls recognize that right away. His grandfather and his granduncle, I guess, he moved to the Pillager area in about 1900 from upstate New York. Bryan's father graduated from high school. He's in the Hall of Fame, correct?
He is.
And but he didn't keep him here. He drug him all over the world because he went into missionary work. And so Bryan was born in Brazil and spent most of his time in Africa. But on graduation from high school, he came back to the United States, went to school at the University of Minnesota, got a degree in forestry and soil science. Am I correct there?
That is correct.
So he's worked for 20 plus years for the DNR in forest soil science, and now since then he's also worked for City Cross Lake, and now he's working for Aiken County doing some work with his own company doing that now. Fancies himself as an amateur geologist, and thus with all this background, he's going to bring us and take us all the way back to the Ice Age. So please welcome Bryan Hargrave.
Thank you. It's kind of nice to get back into God's country here, even though I don't live that far away. I live up between Brainerd and Cross Lake. So, but my wife and I came down here on Sunday and were blown away by the school. That is quite a beautiful school that they have really created down here now, and my dad always spoke very well of the Pillager School, even though he said I kind of spent more time out of the classroom than I spent in the classroom. So we're here to talk tonight about how we got here, why the physical landforms that we have, that you deal with every day, drive through every day, work in every day, are here, and why it developed this way. If you take a look at the background here, I kind of, you can see in the background here, this is the extent of the glaciation of the last glacial period that we had in here. Everything we have around here is due to big ice. By big ice, I'm talking about continental glaciers. So, if we start out with nothing, the original settlers, and I'm not talking about the original European settlers coming from the east, the original settlers that came into this country back 10,000, 12,000 years ago would have had a clean slate here, would know nothing about it. In fact, probably when they came through the Bering Strait there, this area was probably still covered with ice. And so they wouldn't have even come into this country. They went further down to the southwest and the southern part of North America. And then once the ice started going back, they started coming up here and trying to figure out the countryside, how they could live, how they could eat, what kind of shelter they could have, you know, basically all the things that we have to deal with as people now, they had to deal with back then. Well, it started out with a clean slate. And then gradually, as they did some exploring, they found out the general shape of the area, the topography. And in this particular situation, this is a shaded relief map of the state. And everything that is in darker green here are the low areas. Everything that is shaded brown and more to the reds up here, the highest part of the state we have is somewhere up in this area right here. You can kind of see that they would come in here, they would go around and try to figure out, you know, where they could live, how to deal with the topography and so on, and how to get something to eat, how to get a place to sleep. So this becomes part of the putting together the puzzle of learning about where they were going to live. If you put on another layer, now we've got the water on here. And of course, Minnesota is famous for its water. And the number of lakes we have, and it's not only lakes, but the number of, used to be a lot more, but the number of potholes and marshes and wetlands and so on that we have. You can start to see some patterns here. We're sitting right about here. You can see a pattern of lakes going up here. You can see all the lakes all the way around this region in here. Lakes down here. Get down around southern part of the cities there. Quite a few lakes, and of course up in this area, up in the Boundary Waters Canoe area, we have a lot of water. So they would have to try to figure out how to get across rivers. Here's the Minnesota River, Mississippi River coming down here and then down on here. I'm sure they thought they were in hog heaven when they found out that they could use wild rice to eat. Wild rice is a wild grain that the Native Americans used pretty extensively. But as I talk about the Native Americans, the European settlement, they had to go through the same process. They had to learn this country. And they had a whole different set of background when they came in. So they were looking to a great degree more for land, for areas that they could plant crops, harvest, again, have food to eat, have a shelter over their head, be able to live comfortably. A lot of them coming from Europe were coming from situations where land was running out. The only land that was available was very poor. They came in here and they saw this huge, vast area of land and they thought, wow, I'm in heaven. They quickly found out that some parts of the state, they were in heaven. Other parts of the state didn't work out too well. And so, I zoom in on this particular part, the central part of the state, and we see here's the Pillager Gap that we've been asked to talk about, asked to how that developed. And again, you can see a range of hills going up this way. You can see a range of hills going this way. You can see a huge area here where there's a lot of lakes. Crow Wing River coming through here, the Mississippi River coming down, and so on. And again, you can pick up a lot of information just looking at something like this. That was not available to us until about probably between 1980 and 1990. So people had to go out and learn this just by physically going over the landscape and being able to use the land. So, introduction, we want to take a look at the origin of the current landscapes in central Minnesota. How did they develop? And the resulting effects of the landscapes on vegetation, soils, topography, water resources, and land use. Okay, general overview. Here's what we were dealing with throughout the state of Minnesota. There were 5 major glacial periods in the last 2.5 million years. Don't ask me how we know that there were 5 major glacial periods. This is what glacial scientists tell us. And there's records out there. A lot of people going through and digging a lot of holes and looking at a lot of rock, looking at a lot of soil to be able to say that. So the last glacial period is called the Wisconsinan, and I don't know why it's called the Wisconsinan. Why don't they just call it the Wisconsin phase? But it's called the Wisconsinan glacial episode. And that episode was from about 110,000 years ago to about 11.7 thousand years ago, 11,700 years ago. Again, those dates, a lot of times they go down, they find these deposits, they do carbon-14 dating, and so they can kind of get an idea of what time frame they're talking about, and that's where these dates come from. Now, if you think about it, the Great Pyramid of Cheops in Egypt was built about 3,500 years before Christ. So we're talking about a period of time, the last glacial period was to 11,700. It was well before Egypt was developed, well before Mesopotamia was developed. All the ancient history that we go through, you know, this is a long time ago. And since then, there's been a lot of climate changes back and forth, and we'll kind of go through that as we talk about this. So, the big question is why? Why did we have glacial periods? Why did it get so cold that ice developed up in, again, this is the Canadians' fault, right? It developed up in Canada and came south. And so why did that happen? Well, there's a lot of theories and they're theories. And some of them are pretty good, some of them are kind of off the wall. And so there's the Milankovitch Theory, and Mr. Milankovitch was a mathematician from Serbia, which is, it's the old Yugoslavia. And he spent a lot of time looking at the mathematics of the orbit of the Earth around the sun, the way the Earth tilts back and forth, and the so-called Earth wobble as it goes around. And I'm going to, because I have little or no knowledge of this, I'm going to just, so you have first, the Earth's orbit can be nearly circular as it is today. We're almost circular, so we get, but at some point in time it becomes more of an ellipse. And at that point in time, the northern hemisphere gets less sun. And so his idea is, or his theory is, that the three cyclical changes in the Earth's orbit and tilt have occurred over the last tens to hundreds of thousands of years. And that was his thinking for the reason for the continental glaciers. Other theories have attributed them to volcanic eruptions. I don't know anyone here living in 1815? No? Okay, 1815 there was a huge volcanic explosion in Indonesia. And during that time it sent up all kinds of gases and so on up into the atmosphere, up in the upper atmosphere. In 1816 in Europe it was known as the year of no summer. They had no summer, they could not grow crops. Indonesians couldn't grow crops, and they had a terrible time. Hundreds of thousands of people died at that time. So that's possible, but that means that there would have to be volcanoes exploding, you know, regularly all the time. It could have happened, I don't know, but that's another theory. Other theories attributed to major changes in the ocean's current. In other words, Europe gets a current that goes by it, the Gulf Stream, that basically, I think it's the Gulf Stream, it basically warms it up. It's basically at the same latitude as we are, but they're a lot warmer than we are, for the most part. So they're thinking, okay, there were, for whatever reason, there were changes to the ocean currents, and that affected the climate so that the glaciers developed. Take your pick. I don't know. I mean, I'm just telling you what some experts are saying here. However, the one thing we do know is they occurred. The glaciers occurred, and we have a lot of evidence of that. We see glacial landforms. We see very young soils here in Minnesota. If you go down to Brazil, and some of those soils down there, it's actually almost like bedrock because they have been there's so much water have gone through them that everything is just drained out of the soil. And so those older soils are not nearly as productive as what we have. So we know that the glacial periods occurred. And here's the good news. Scientists predict that the next glacial period won't happen for the next 50,000 years. So at least most of us don't have to worry about that, right? Okay. I don't know how they know that, but they do.
I have a question.
Sure.
Did this happen anyplace else on our Earth?
It happened in Northern Europe around, if we go back, to this slide right here, you can see it went all the way up along the coast here. This is North America here. Here's Greenland here. And then here's Europe and into Siberia and parts of Siberia and so on. So it happened across the northern hemisphere, basically, of the continent. So if we take a look at what the extent of the ice sheet was, you can see here, it's all across northern Montana, most of North Dakota, into parts of South Dakota. The only part that was not glaciated in the last glaciation was the very southeastern tip of Minnesota, down by Caledonia. It would be southeast of Rochester. It's basically, that was an area I started working down there after I got out of college. It's an area called the Driftless Area. It's called the Driftless Area because there was not any evidence of glacial materials there in the soils. But it was only driftless for the last glacial period. It had been glaciated before that. There was a Illinois and Nebraskan before the Wisconsin glacial periods, and so we did find evidence of the older glacial material down in the southeastern corner, and also the southwestern corner of the state. And that is, you know, Buffalo Ridge, the Coteau, Prairie de Coteau, the very high ridge that now if you go through that area, you see all the windmills going. And that's where there's a lot of wind activity in the southwestern part there. So those are the only two parts, and then up into Wisconsin here a little bit, there was an area here that was not affected by glaciation. But you can see it goes all the way across into Illinois, half of Indiana, half of Ohio, all of New York, all of New England, and then all of Canada. Wasn't much ice activity in Alaska, which is kind of interesting. So that is the extent of the ice. Now, if we take a look at how thick the ice was, this kind of blew me away when I started taking a look at it. But I had always been told that the ice, the continental glacial ice here in Minnesota was over 5,000 feet thick, over a mile thick. I pulled this up off of a scientific journal, and you can see right there is a topographic line right in here. This is in meters. So you have to take that times 3. So at the center of the continental glacier, it was over 9,000 feet thick, the ice. As we get down closer here, here is 6,000 feet. Again, I don't know how in the world this was developed, but they took a look at the thickness of the ice and the way the ice moves in a glacial time frame, the way it moves forward and so on, and somehow they developed these contours. Now, if you think about that, we were in Yosemite in the spring. That's El Capitan, which is one of the big glacial granite ridges in Yosemite. It's 3,600 feet from the valley floor up to the top of El Capitan. If you think if the ice was 4,000 to 5,000 feet, it would be way up here. That's really thick. And what happened is that ice was so thick that it was able to crunch rock up, redeposit the rock as soil, as soil type material. We're also getting parts of the earth, the northern hemisphere, that are still recovering from the weight of the ice. It's still uplifting because it's reacting to the ice being gone 10,000 years later. So I mean, that's how thick and how heavy that ice would have been. I tried to figure out how long it would take if I dove off the top of El Capitan and hit the valley floor, how long that would take. It'd take about 20 seconds, according to, you start accelerating and you reach a certain point and you stay at the same speed all the way down. Hopefully then the parachute would kick in. Go ahead.
Is this area uplifting yet?
What's that?
Is this area uplifting?
Yeah.
It is.
Yep. It's very, in millimeters, but it's still uplifting per year type of thing. So, yep. Again, when you stop thinking about the thickness of that ice and how heavy that weighed, and all the material it was carrying. I mean, the ice caps came down here from Canada, and so they were grinding up rock and incorporating all kinds of material into the ice as it was coming down. And in fact, much of the soil and everything that we have now throughout the state and throughout the area that was glaciated was due to the ice grinding stuff up and redepositing it down here. As it melted back, then all that material that was incorporated into the ice, it just flowed out. And so southern Minnesota, southwestern Minnesota, it's got wonderful soils. And we'll go into why that is as we go further on here. Here was the other effect of the ice. So as we have this huge continental glacier coming down, basically the sea levels drop because it was taking up so much moisture that the ocean was going, and the ocean receded went down about 400 to 600 feet. And in doing so, it developed a land bridge across between Siberia and Alaska. And people in Siberia then saw a nice bridge to go across, and they thought, I wonder what's on the other side of that. And they walked across, and how do we know that? Well, there's actually genetic evidence. They've taken a look at the DNA from our Native Americans here in North America and taken a look at the DNA from natives of Siberia, compared them, and they're related. So there were some other theories about maybe from Europe, they took a boat over. I don't know if the Queen Mary was running then or not, but and so on. But it looks like, again, we're going back in time thousands of years, and so we're just getting a little bit of knowledge. We don't have a lot of, aside from the landforms and And the information that we can gather from the soil and from bodies we can find and that type of thing that was back then, we don't have very much information. But the best theory right now is that North America was populated coming across from Siberia and then people moving down across North America and South America.
I have a question.
Sure.
I'm just not getting how this ice made the water go down. I mean,
Because there's only so much moisture in the air.
Okay.
So this ice developed because what happens is it starts snowing, like this winter.
Oh, it's winter.
I thought we were going to have some glaciers moving in here. It starts snowing, and it snows and snows, and it doesn't melt. It does not, and so it just keeps on piling on top of each other. And so it's all at some point in time it's incorporated into ice. It gets condensed and becomes ice, and then it gradually builds up over time. Remember, we're talking about thousands of years here. This ice age ran from 100,000, pretty close to 100,000 years. That's a long time for, So there's only so much moisture in the atmosphere. And if it's incorporated into the ice and it's not being relayed to the sea, then the ocean is going to go down. This is the geologic map, the Quaternary geology map of the state of Minnesota. This was put together by a couple of gentlemen that did phenomenal work. This was put together, this was published about 1972. And this was the map that I grew up with. And you can see, we're going to talk about these various lobes and so on, but this ice lobe here decided it really liked it down in Des Moines, Iowa, so it went down to Des Moines. So it's called a Des Moines lobe. And there were lobes that came over this area, there were lobes that came over this area, there were lobes that came out of the Lake Superior Basin. So that's why you're seeing colors here. These red colors are materials that were put down from the Lake Superior lobe, or the Superior lobe. And we'll get to how it affected the soils a little bit later, but this gives you an idea of all the various types of, these were deposits that were put down. There's glacial till, we'll go over those definitions. There's outwash, there's erratic boulders, there's lake sediments. There's all kinds of material that glaciers or factors involved with glaciers lay down. So here is central Minnesota again. And again, you can see there's the Pillager Gap right there. And if you could see these, basically, this is outwash sand going through here. You can see hills going up this way, hills going down this way. At one time, both of these, this was all one set of hills through here, and we'll figure out how that gap developed in time. Yes, sir?
So you have sand.
I'm sorry, ma'am.
Upper of your high ground. What are your soils that you're looking at there?
So this area in here is basically the Crow Wing River outwash plain, basically. This is, on this map, they called it outwash. And we'll go through the definition of that. So if you're familiar with this area at all, you know the gap is pretty sandy. Has a lot of sand. And the area around Brainerd has got a lot of sand. And when we get 8-inch rains, I'm so thankful I'm living on sand, because 2 days later I've got to water the lawn, right? Yeah. Okay. So, and we'll take a look and see how that developed. But this part in here they called outwash. And we'll see, and this was 1972, we'll see later how that idea changed. And actually, they were able to figure out why that gap developed in there. Okay, so I call this the dance of the glacial ice lobes. And this really is a dance here. There's a Wadena lobe that came over from this area here. That was the earliest lobe of the last glaciation. And so it came down here, it formed a set of hills across here, and then we get this rainy lobe material coming in here and the superior lobe. And then this went back, that went back, and then the Wadena lobe came back down again and formed, you know, south of Leech Lake there's that real hilly area with a lot of lakes, formed that area in there. And this Brainerd lobe here came back and formed the set of hills we have that basically run north and south here, which we have a gap through. Okay? And then we had this Des Moines lobe come down. And then there was a Couchiching lobe that pushed through here and came all the way over into Crow Wing County, just barely into Crow Wing County. And then it went back out, and this went back out, and this went up. So you can kind of see how everything is, and we're talking about thousands of years here, but I mean, it really is a dance of all these lobes that advanced, retreated, and formed all these landforms that we deal with. And sometimes they overrode earlier lobes, and so you have red material over brown material, or brown material over red material. It gets pretty complicated sometimes.
What happened to all the water when it melted?
Ah, water. It started flowing. Actually, the Mississippi River, there wasn't much of a channel for the Mississippi River 10,000 years ago. The Mississippi River was a stream, very small. But basically, in front of these lobes, especially as they were melting back, you would have water flowing off of them. And whatever was the lowest area, you know how water moves. Whatever's lowest, you know, it goes down in that direction. We'll get to some of that a little bit later here, but definitely there was a lot of water. There was also a lot of huge glacial lakes. Now, if you go over to Alexandria, and you head due west of Alexandria over toward the small town of Wheaton, Minnesota, if you know where that is, you get to the little town of Herman, and you go over a bump, and after that bump, this floor here is not quite as flat as that area in there. And I worked over there too, so I know that area. And I remember once I hit the flat area there, west of Herman, my foot would go down in the accelerator because there are no landmarks for you to be able to key on. It was just flat country and black prairie. I mean, it was just crops everywhere. There's nothing for you to focus on. Pretty soon I'd look down, I'm going 90 miles an hour, and I didn't even realize that, you know, what the heck was going on, and I had to pull back because that landscape is so flat. And you'd think, if you could see 15 miles to the horizon, that people that are going down roads would be able to see cars coming. We had accidents, people hitting each other at intersections and so on because they weren't paying attention. But in that flat landscape, so there was a huge lake here called Glacial Lake Agassiz. And that went all the way from way down here, all the way up into Manitoba. Upper Red Lake, Lower Red Lake, Lake of the Woods, Lake Winnipeg, all those lakes are remnants of that huge glacial lake. Periodically, there was a plug right down here at Browns Valley. Periodically, that plug the water pressure would push it through, and then the water would race down what's now the Minnesota River Valley. Well, if you've ever gone down to the Minnesota River Valley, you notice there's this huge valley, 5, 6, 7 miles wide. And there's this little river running through it. And the reason for that is because a lot of the water, remember this whole area in here was all water, all lake, would flash flood all the way through that and just clean it all out. And what we have left now is the Minnesota River. Much wider valley in the Minnesota River than we have in the Mississippi River. So there are other glacial lakes here. There was a glacial lake Aiken and Upham in Aiken County, and that's why when you go through Aiken County, flat country again. That was a glacial lake. We had one down here called Glacial Lake Benson. We had one here called Glacial Lake Grantsburg. So there were lakes that developed as the ice was melting back. It would form a barrier, and then if there were enough hills around the edges of it, it would hold the water in and it would create these large lakes. And then it's at points in time that they would bust out and take off down whatever channel they could find and create some big areas of fairly, and as a matter of fact, that's related to the Pillager Gap, so we'll get to that in just a minute. Okay, so let's talk just a couple of terms here, and I'm not going to go overboard on this. So an outwash plain is the area in front of the glacier as it's melting. And what happens when water is carrying sediment? What comes out first? The heaviest sediment, right? And so you get the gravel and the sand dropping out first, and this is called outwash because it is fairly sandy and gravelly, and in many cases, if it's called a pitted outwash plain, that means that there were ice lobes or ice that was enveloped by the outwash and then melted out later. And so it becomes pitted. Okay, moraines. Here's an example of a moraine when the ice stops moving. You can imagine a huge bulldozer. I mean, we've talked about the thickness of the ice. You can imagine a huge bulldozer that has all kinds of material in it. It's pushing all kinds of material forward. Then when it stops, you get this ridge. And this is a very small example of that, but you can, I don't know if you can quite see this here, but there's a ridge right here all the way around this lake here. So this would be where the glacier stopped moving forward and started melting back. Okay, so that is a moraine. Now you can have lateral moraines that develop on the side of the ice. You can have terminal moraines that develop on at the end of the ice where it stops. Drumlins. If you drive over to Motley, is it a different type of topography that you run into rather than topography you run into here? You know, you kind of go like this, up and down and up and down. If you really want a roller coaster ride, go over to Staples and go take 210 over to Hewitt. And that is like, it's just up and down, up and down, up and down. That's because there are drumlins in those areas. And drumlins are like, I call it like a half-buried egg formed when glacial ice, it happened underneath the ice. And so you get these very distinct shaped hills that the ice was moving this way. So the ice movement was this way, so it was flattening out this part of the drumlin, and this part was left deposited. So now you can tell your neighbors, you know, if you go west of Staples, those drumlins are really something. Okay. Eschars. Eschars are like upside down rivers. They were rivers in the ice, developed. Again, coarse material dropped out. This is a excavator's dream to find one of these, because that's nothing but, in general, sand and gravel. And so there's a lot of mineable material, but there's a huge one down by Camp Ripley. If you go south, there's even some in this area you can you can take a look at, but that's a very distinctive. It looks like an upside down river, basically an upside down riverbed. Okay. And then the types of material the glaciers laid down was till. Till could be just unsorted material. Just nothing is just sand, silt, clay, gravel, rocks, and so on. So that's what we're talking about when we talk about till. Outwash are deposits of sand and gravel carried by running water from melting glacial ice and laid down in stratified deposits. Erratic boulders. This is one of the things that scientists started taking a look at over in Europe. They got these huge boulders that they would find in close to the foot slopes of the Alps. And they could not figure out why in the world, because the rock was nothing like the local rock around. It wasn't as if, you know, you had the Egyptians pulling on this thing and pulling it up the hill. It was rocks, rounded rocks that were left in place, and they couldn't figure out how in the world that happened, because these rocks were, the origin of the rocks could have been hundreds or thousands of miles to the north. And so they started looking at that, and that they're called erratic boulders, or erratics. And they're large rocks dropped by glaciers far from their origin. I'm sure many of you, if you're farmers, you've run across rocks just buried in the soil. And I ran across one today. It was about like that up by Hill City. And I don't know why it was there, but the ice just dropped it in place. And then lake deposits, which is sediment deposited at the bottom of glacial lakes, or any lakes. I mean, even the lakes we have here are depositing lake sediments. Now, okay, so if we go into a little more detailed analysis of this particular area, we can see here Wadena Lobe coming down, Rainy Lobe is here. Wadena Lobe is the till that it carried was kind of a brownish, yellowish till. Didn't have, a lot of times what they look at, when they look at till, they look at the origin of material. This came from probably north of Kenora, up in Ontario there, up by close to Hudson Bay. It's fairly good material, but it doesn't have a lot of calcium in it. And you can measure calcium. I used to carry, as a soil scientist, I used to carry a little bottle of sulfuric acid with me. And I had it on my belt. And then when I dug into the soil, I looked at to see if it's calcareous or not. It had calcium in it. I could drop the acid in it. If it fizzed, then there was calcium there. And so this is fairly low in calcium. This Rainy Lobe came over the BWCA area, so it's a brown till that is fairly low in, it's more of a sandy loam type of material. And of course, the Superior Lobe came out of the Lake Superior Basin, and there was a lot of red sandstone in there. So a lot of that Superior Lobe material was really red. If you go east of here, over in Pine County and down Mille Lacs County and in that area, if you start digging in the soil, it gets pretty red pretty quick. And you can tell from that where the source of the material was. Okay, so you have these. Here is Cass County right here. This would be west of Cass County, all the way over here, and it created a moraine. It created a big set of hills west of Cass County here. Melted back, came back. This is the Wadena Lobe here, and it formed that set of hills south of Leech Lake. Here's the Brainerd Lobe of the Rainy Lobe. It came back, and here is the moraine that we have, the gap through here. So what we have, that set of hills we have to the north, set of hills we have to the south, is a moraine system. That's where the glacier stopped and started melting back. When it came back, a little bit of the ice went over the top of it, but not much. Okay. So here we are, right down here. And remember I was talking about the glacial lakes. Well, east of here, there was a glacial lake that formed. It was called Glacial Lake Brainerd. I wonder who thought that up. Man, that's a unique name. Okay, Glacial Lake Brainerd. Basically, there were big ice blocks and material was piled on top of it. Any of you remember going out to lakes and cutting ice in the wintertime and bringing in blocks of ice and storing them so you could use it in the summertime? Nobody?
Yeah.
I don't. So but what happened was you have material on top of that ice. It created a shallow lake. That shallow lake then got high enough, and there probably was some kind of a gap or a low area in the set of hills that on the north and south of us here, that meltwater that you were talking about came off of Glacial Lake Brainerd here and flowed to the west and flowed down where the Long Prairie River is. Flowed down that channel because that's an old channel. Okay? And so this is the lake, but this is all meltwater that's coming off of the glacier here. You can see it came through up here, melted down, water was coming down there. So further on, here again, is that moraine. Here's the gap right here now. And now this lake melted out, ice blocks were left, and what happened? Well, if you take a look here, you've got North Long Lake, Round Lake, all these lakes in here were left as a result of big ice blocks that were left in the material, and then after they melted out, they created the lakes. And so that's why we have so many lakes up here north of Brainerd. Okay, so then they were moving out, and then this doggone Couchiching lobe came in and created, it didn't get it as far as here, but it got into eastern Crow Wing County, and basically the Long Prairie River here began to flow through this gap and down into that what is now the Mississippi River channel. And at the end, we had a huge block of ice out. I'm looking at this map right here, but thinking about the state, there was this Des Moines lobe that was sitting way out here, and all the meltwater off of that flowed to the east. And then that created the flowage for the Crow Wing River. And the Crow Wing River came through that gap right there into the Mississippi River and down. So that is basically the reason why we have that gap in there. There was a glacial lake to the east. It was high enough so that the meltwater was able to break through this set of hills right here, right in here, and then was able to actually flow out to the west at first. Once everything melted back and the big ice was over here, it reversed its flow and flowed to the east.
So the gap was basically caused by water?
Yes. Yep, it was cleaned out. So I spent some time over here trying to get some pictures of the area. This is up north of town on 1, and you can see how flat it is. I mean, it's just, once you get past south of Pillager Lake, it just flattens right out. And you can see the agriculture in here, but again, very flat. But if you look to the north, you can see the edge of that, and you can see the hill starting up in there. Same thing here, looking from the south, I went south on 1, and then once you get up on top, up just where Camp Ripley starts, and there's a water tower down at Pillager, and you can see real nice hill here. At the narrowest point, that gap is about 3 miles wide. And so it just got blown through there by water. And then it became a natural place for the water to flow through once all the drainage areas were developed.
So is that land any richer than, say, the land on top of the hill?
No,
No?
because it's pretty sandy. And we'll go into that here in just a little bit. So here is a picture of a glacial moraine that's up. They must be doing a lot of logging up in the Pillsbury. And so this was on the Pillager truck trail or the Pillsbury Road. And was able to, you can see a moraine has got short choppy hills, quite steep in many places. If there were fine materials underneath here, there'd be a little lake down there, a little body of water. And that's true throughout the hills there. There's little lakes sprinkled all through that area. Okay, results in the vegetation, the soils, hydrography, the lakes, rivers, streams, and wetlands, and the land use. And I'll try to go through these pretty quickly. This is a map that was put together by a gentleman by the name of Francis Marshner. And Mr. Marshner never stepped in Minnesota, in the state of Minnesota. He was in Washington, D.C. He took the old survey records. The land survey started in about 1840 and went through 1910, right around that era. But he took all those notes that the surveyors made, because the surveyors, when they set their monuments, they had to document where that monument was, and they documented by having witness trees or bearing trees. And the bearing trees, they would take an axe and they would scrape off a little bit of the bark, and they would burn in, and then they would document what kind of a tree it was. They would document the diameter of the tree, and they would document the bearing to the monument from that. So they would have 3 trees in the area for each section corner and each half section corner and so on. And they would document what kind of trees. Well, he took those notes from the original surveyors and actually made this map without even stepping a foot into Minnesota. Okay, so you can see basically 3 patterns. The yellow here is prairie. This is all prairie over into here. This purplish area in here it's called the big woods. It's basically oak, maple, basswood. It's species of trees that actually are not pioneer species, but they come in after the pioneer species come in, and then they take over and they create such shade. If you've been in a maple forest, there's not very much sun on the forest floor, and so on. So that, and then the pineries were up here. Is to take a look at the pineries in this part of the state. So everything in brown here are red and white pine. Okay. Now I've talked to a lot of people. They have the idea that most of this area was pineries. It wasn't. You can see that there were blocks of this blue in here and up here. Those are areas that were predominantly white pine. So these yellow areas, aha, jack pine. Who likes jack pine? No? I don't think anybody does. Anyway.
Wrong.
Yeah, so you can see in the gap here, that's basically what was here. Why jack pine? Well, for vegetation, there's another factor that comes in here, is that there were periodic fires that went through the state. And the fires made a huge difference. Jack pine is a pioneer species. In other words, it loves to populate areas that have no competition. Aspen is the same way. Birch is the same way. A lot of times you see solid stands of birch. And the reason is Probably it was burned off, birch seeded in, it was able to come up without any competition. So the other thing about jack pine is that it will grow very nicely on sand. And so you can see here how much jack pine we had, and a lot of that area is sand. It just does not compete well on the finer textured soils. Okay? And again, just to take a look at this area in here, you can see that there weren't huge areas of pineries. But the loggers would quickly find these really good areas here, go in there, buy up the land, take down the trees, let the land go back tax forfeit. And when that happened, it went back to the state, and in many cases the state turned it over to the county. So that's why we have very large blocks of public land here in the state of Minnesota. Okay, and here again, these green areas are aspen birch, and the brown areas are aspen birch that are trending towards hardwood. So you can see how much aspen birch there was. Marshner called this the original vegetation map of Minnesota. There's nothing original about it. It was just a slice in time. And this changed back and forth, the vegetation and so on. But aspen was definitely a part of the whole landscape back when the European settlers came in. And a lot of it was due to fires. Soils of Minnesota, I didn't try to, I looked for a better statewide map, but again, here's the gap, here's the yellow, and it's, I think it says, no, it's right down here, coarse to medium textured forest soils. And so that's what was in the gap area here and throughout much of Crow Wing County, was that coarse sand, medium sand, fine sand, and that's why we had the vegetation the way we do. Okay, so this is that field north of Pillager again, and I zoomed in, and you can see here the center pivot irrigation. Now there's three reasons why you have center pivot irrigation. One is because the soils don't hold enough moisture to be able to just give enough moisture to the crops so that it'll go through the season. Number two is it's flat. So you don't have to go, that center pivot irrigation doesn't have to go up and down. I mean, it's nice and flat. Number three is there's plenty of groundwater. And so they can dig a well, put that in there, and then actually irrigate the crops. And that's one way you get a decent crop off of real sandy soils. Okay, so this area in here, although to the settlers, they probably came out here and said, oh wow, nice flat area, it's beautiful. You know, got a bunch of jack pine I got to take off, but that's not a problem. You know, so, but once they started working with the soil, they quickly found out that there were limitations for agriculture. Because it's pretty sandy, you need to get fertilizer on it. You need to make sure that you have enough moisture for a crop. And so in this particular area, it didn't work out too well as far as agriculture. So this is a land cover map for central Minnesota. Again, here's the gap right here. And you can see cultivated crops. I don't know if you can see it all that well, but there just is not, this is all pastures and hay in here. Here's what's interesting. This is still all forested in here. Here are the hills to the north of Pillager. Here are the hills to the south of Pillager, all forested. That green is deciduous forest. So even to this day, it did not make good agricultural land. They might have cleared it off, they might have sold the wood. It did not make good agricultural land, so they let it go because they couldn't make a living on it. as far as raising crops and that type of thing. I mean, this area in here, again, looking at that morainic type landscape, hills going down to bottom, I mean, it was very hard to grow crops on there. So it has now become, you know, Camp Ripley is down here. There's a lot of public land going up this spine right here. And you can follow this all the way up to just south of Walker, south of Leech Lake there. And that whole area is the same way. But water-wise, now this is where we shine. Look at the lakes here. Here's Gull Lake, here's Sylvan, North Long, Round, Hubert, Pelican, Edward. Look at how much water we have here. That makes for a very wonderful situation for people who want cabins. And also to be able to use the rivers for generating electricity. This is the Pillager Dam. As you can see, it's flowing very nicely this spring. Recreation. Here we've got a bunch of slackers, you know, with fishing poles. Having a good time. And again, there's a boat out here, there's people on the dock over here. You can't see it too well on the wall here, but you know, this is what this area is known for. It's not known for generating crops. You have to go further south for that. And mining. Now, by mining, I'm not talking about hard rock mining. I'm talking about gravel and sand resources. And you can see here just north of town, just east of town, there's all kinds of pits. There's pits all around here. There's a lot of rock in here. They can crush that down. They can make nice class 5. They can make sand. They can make gravel. And it's perfect for people who need to put in a cement base or put in a road or that type of thing. I mean, it's really a nice situation. In fact, globally, they're talking about there's a dearth of sand, that they see that there's so much development going on that at some point in time in the next 30, 40, 50 years, they're going to be exporting a lot of sand and gravel because there just isn't that much left in the world today. And, of course, the lakes. This happens to be a little piece of Sylvan Lake on the south side. Now, I'm not sure. My uncle and aunt had a cabin here on Sylvan. I think it was right around in here, or maybe a little bit further to the west. But we used to, when I came back from Africa, it was really fun to go to the cabin. Go ahead.
You talked about the lakes like Round Lake and North Long Lake and so on being formed by, for lack of a better term, a huge ice cube that got left at the bottom.
Yep.
I think you told me that Sylvan and Gull were formed differently.
Well, let's take a look at that a minute, real quick. Go back here to the... I was going to make a point of this, but you see how these shorelines here on these lakes are very uniform, nice round lake is a good example. You know, these are bowls, basically, in here. Take a look at the formation of Gull Lake, particularly on the south end here, Sylvan Lake. As a matter of fact, if you, well, I can't really zoom in here, but you know, if the glaciers had just carved out a little bit more of a channel on Sylvan, you could have been right into the Gull Lake chain and all the way up to Nisswa. But it didn't. So, I mean, some of these are called tunnel valleys where the water came out. There was ice blocks left, and so you've got long, narrow lakes, a lot of bays. There's a lake over in eastern Crow Wing County called Bay Lake because it has a lot of bays. Lake Minnetonka down in the cities, west of the cities there, is a very good example of a lake in a moraine. It has got tons of bays, and the shoreline is just all over the place. But you can see here on the sand plain where you just had blocks of ice that melted out, very uniform, lovely shoreline, and just a different type of a lake than we have on these areas. You're down here, Alexander and Chaminade and Fish Trap. Again, you can see the difference in the type of shoreline that's there. Yes?
So would those lakes such as Gull have a tendency to be deeper lakes?
I'm sorry?
Would those lakes such as Gull and Sylvan tend to be deeper lakes?
In many cases they do. In many cases they do. In many of these the lakes that were caused by ice blocks, you have a deep point and then everything else goes up from there. Whereas actually Pelican is on the edge. It said if you would drop the level of water in Pelican Lake, you would have 5 different lakes because there are holes there, and at one point down here in the southern end of Pelican, and I live right up here, southern end of Pelican, it goes down about 130 feet. Okay, and so you can see here, point I'm making is that you can see very nice houses now. It used to be all just cabins along there. Now, you know, people are making their permanent homes here and they're putting up very nice places. And it makes for a great situation for county tax purposes. But the big draw again is the water. And it really attracts a lot of people and has for a long time. This happens to be in Gull Lake. And this little piece of property right on the end, what is this? This is Birch Island on Gull Lake. That little piece of property right there is worth about $1.5 million according to the Cass County Assessor's Office. So I mean, you're talking about a lot of value, and you look at the homes along here, they are not 1-bedroom cabins. In Cross Lake, when I worked up there, people would come in and drop these plans that were about that thick and about that long and about that wide. I want to build my cabin. And I'm going, how many bedrooms? 5 bedrooms? Huh. How many square feet? 5,000, 6,000 square feet? That's quite a cabin. So, again, what nature gave us was a lot of water resources in this area. We got the Crow-Wing River, we got the Mississippi River, we got the, you know, all these and smaller rivers and streams and so on, as well as the lakes. And we have some very nice resources as far as that goes. So, we started with a clean slate. We ended up with a full plate. Glacial history and the resulting landforms have affected our current use of the land in central Minnesota. And we also found out that the Pillager Gap was created during the last glacial period, resulting in the Crow-Wing River flowing through on its journey to the Mississippi River and the Gulf of Mexico. And that's my story, and I'm sticking to it.